two facts are going to allow us to use factors to simplify fractions. Both of these we've talked about before. First of all, any fraction that has the same numerator and denominator is actually equal to 1. Well, except for that special case where we have 0 over 0. And then fractions are the same idea as division. They mean the exact same thing. I want you to think about this fraction I have right here. Now this is really 4 over 10, but I've written it differently. I wrote 4 is 2 times 2, and 10 is 5 times 2. So that means that both 4 and 10 have factors of 2. That's that shared factor thing I talked about before. All right, so like I said, it's the same as 4 over 10, so that means it's the same as 4 divided by 10. If you put that in your calculator, that's 0.4. Okay, so if I have 0.4, what happens when I divide 2 by 5? I also get 0.4. Where'd this 2 and 5 come from? Take a look at our fraction over here. If I get rid of this 2 and this 2, what am I left with? 2/5. So the shared factors don't really matter. So if I have shared factors, that means I can basically get rid of them. And the reason is because of this first rule up here, that any fraction with the same numerator and denominator is equal to 1. So this 2 over 2 right here is basically a 1. I'm basically saying 2/5 times 1, which is the same as 4/10, but it's a lot nicer to write it as 2/5. Basically, the shared factors are extra information. They're unnecessary. So I want to get rid of any shared factors. Let's take a look at another one, 55 over 25. Here's another trick. If a number ends in 5, then 5 is a factor. And that's probably the first thing that I'm going to notice when I look at this one. All right, so I think, okay, I know 5 must be a factor of 55. So on the calculator, you can check 55 divided by 5 gives you 11. All right, 25, you should know, is just 5 times 5. So now I have a 5 and a 5, and I can eliminate both of those and end up with just 11 over 5. Now 11, there are no factors other than 1 and 11. It's a prime number, which means the only factors are itself and 1. And then same with 5. So this is simplified completely. So 55 over 25 is the same thing as 11 over 5. They mean the exact same thing, but one is simplified down. Why use this when you can use this? Now let's look at another one. 100 over 1,000. All right, remember when a number ends in 0, then 10's in factor. So if I divide 100 by 10, I get 10. So 100 is 10 times 10. And if I divide 1,000 by 10, I get 100. So this is 10 times 10 over 10 times 100. I'm going to cancel out these two 10's here, and I get 10 over 100. Now this isn't simplified yet because they both still end in 0, so they're both still divisible by 10. So this is 10 times 1 over 10 times 10, and I can cancel out another pair of 10's right here, and I end up with 1 over 10. Now notice this is what I was talking about before. If we use the biggest factor that they both share, then it's only going to be one step. But if I just notice factors, I can keep going until I get to the final answer. So you could have gone in one step if you recognize that 100 is a factor of 1,000. So you could have done this completely differently. There's going to be many ways to get to the same answer. As long as you can think of two numbers that multiply to get the numerator and just one shared number down here in the denominator, then you're going to be able to go the next step and keep simplifying. Okay, so again, greatest common factor will save steps. But if you just eliminate common factors, you'll get the right answer. Let's try one, 18 over 36. Okay, when I think of 18, I think of 3 times 6. Maybe you think of 2 times 9, that would work too. Okay, now at 3 times 6, I say is 36 divisible by either of these? It is. 36 is actually 3 times 12. Now look at already, here I could have also said 6 times 6. It totally depends on what you're going for and what you think of first. Okay, so I can cancel out those 3's. I got 6 over 12. Now both of these are even numbers, so I know they share a factor. I know also that 2 times 6 is 12, so there's a couple different ways I could go with this. So if I recognize that 2 times 6 is 12, then I can say, okay, 6 is 6 times 1, 12 is 6 times 2, cancel out the 6's, and I'm left with 1/2. You could have done this a completely different way though. What if you noticed that 36 is 18 times 2? So this is the same problem but done a different way. 18 is 18 times 1, and 36 is 18 times 2. 18 is actually the greatest common factor here. When you eliminate the 18s, you get 1/2. So this is the difference. This is why I mentioned the greatest common factor. If you recognize the biggest factor you can, you're going to save yourself steps. If it's the greatest common factor, it'll be 1 step. But even if it's just the bigger factor, you're going to cut it down from maybe 2 steps, down a little bit. Okay. Here's a picture to kind of show you how this works. This picture right here has 36 squares, and I colored in 18 of them. And if you take a look at the picture, I covered half the squares. So this is what we were talking about before, where fractions can represent the same thing in different ways. So 18 over 36, coloring in 18 out of 36 squares is the same thing as coloring in 1/2 of the squares. That's what we're saying when we simplify. We're saying there's an easier way to say this. You can just say you colored in half the squares instead of you colored in 18 out of 36 of the squares. All right, I want to look at a few more examples before I let you try some. All right, 74 over 22. Now this one, I didn't immediately think of 2 times 37. I don't want you to think that I just somehow knew that in my head. But I did know 22 is 2 times 11 from my multiplication tables. Now if 22 is 2 times 11 and 74 is even, then all I had to do in the calculator was divide 74 by 2. 74 divided by 2 is 37. So I said, okay, 74 is 2 times 37. Cancel that out, and 11 is a prime number, meaning it only has the factors of 11 and 1, so this is as far as I can go. Okay. 16 and 48. No, several things I could think of here, right? 16 is 2 times 8. 16 is 4 times 4. Well, what if I went with 4 times 4? Well, 48 is also 48 is 4 times 12. So I could say, okay, I got 4 times 4 over 4 times 12. Cancel out the 4s, I got 4 over 12. Now, you should recognize that 12 has a 4 inside of it. In other words, 12 is 4 times 3. So I can cancel out a 4, and I end up with 1/3. All right, finally we have 65 over 5. So 65 over 5, they're both end in 5, so I know they have a factor of 5. When I divide 65 by 5, I get 13. And 5 is obviously 5 times 1. Cancel out the 5s. I get 13 over 1, which is 13. So you just keep canceling out factors that are present in both the numerator and the denominator. And use your calculator here. Each time I went through these, I would check in the calculator to see, okay, for example, with the first one, what is 74 divided by 2? I don't just know that in my head. I check.